So we will be starting our week 8. So let me start sharing the screen, and here is the screen that we will be sharing on. Okay, so as in continuation with our week 7, now we are going to look into week 8. So application of arrays. So like we will discuss about how the arrays will be useful and how it will be doing the advanced things that you would like to do in your programming using the array concepts. So how, for example, the first one is copying of arrays. So if you see here, often in a program, you need to duplicate an array. So sometimes you may need to copy an array, or maybe you want to copy a part of an array. In such cases, you would attempt to use the assignment statement equal to as follows. So list2 is equal to list1. So say, for example, you are having list of 1 and you want to have the same list copied to the list 2. So generally before the assignment, so list2 is equal to list1. So here you can see that we have list1 and we are having a content of list1, and we have list2 and we want the content is same like what we have in the list2. But what we want to do is we want to have the list2 also with the same elements as to that of in the list1. So we use list2 is equal to list1, and we want to say that the list2 items elements are all the same elements as that of in the list1. So this is copying the array. So that's not as simple. So we have to write some method, some function to do this job. So what is that function that we will write? Say, for example, regarding the continuation. So we have an integer array, source array, and we are having some elements. And now we want the target array to be that of the same elements. So we want those elements to be same as this one. So what do we declare? So integer target array is an array which is a new of integer, which is according to the source array dot length. So the size of this array will be equal to the size of the source array. So that because you have to make the size to be of equal length. So this size we don't know. So we want to get it with the method dot length. So we have here source dot length as the method. So you can see here that we are having the source dot length will get you automatically the length, whatever may be the length that we have here. Now we want to copy it from index 0 to, because you know that the index starts from 0. So from the 0th index, we will continue up to the length that we are having. So less than source dot length, and increment, keep on incrementing it. So the new target at the index of I, that is index of 0, is also equal to the element at source index of 0. So this way the for loop will continue until the source dot length is there. That's how you can copy the arrays from one array to the another array from using the method, which is you will declare it and you get the length of that and you can copy directly. So next one. So here what we are doing, we are using an utility also is available in Java. That utility is array copy. So here what we are doing, we are making the source and the target, and we are doing a for loop method. So rather than that, we have one of the other utility, which is called as array copy. So array copy is available from java.lang system class in Java. So this utility is available there. So no need to reinventing the wheel. So we can simply copy the source to the target by using the array name, the method name array copy. So array copy, whatever may be the source array that we want to use, and what is the position that we have to start from, and the target array, and the target position where do you want to see, and the length of the source, you know that. So we have the source array, so source position that we want, and then we want the target array, what is the target position that we will give, and copy it up to the length of the source array. So here we write system.array copy as a class that we can use. So same thing, source array, and the position that we want is from the 0, and then we want the target array, and then from the target array, the position, and whatever may be the length that we are having, we can use it directly to copy the array from one source to the other source. Next. So what we are doing here, you can just see this one also, passing array to the methods. So one more thing, we want to pass the array to the method. Now, earlier we copied, but now this is a method that you can use to pass on the array elements. So say for example, we have here public static void print array. So print array is the name of an array, and we are getting the arrays directly passing arrays to the method. So we want to use this array. Now, from starting to 0 to length, array.length I plus plus. So we want to just read the elements and print it back. So the elements are passed from an array, and all the elements that you are giving, it has to be printed back. So when you invoke the method, what will happen? So this list, that whatever we have here, is given to the directly to the method. So now we are calling the list with the array name here. So what we will write here, print array of list. So the method name is print array, and with what array list that you want to call with. So we want to call with the list over here. So this list is being given to the print array. Now what the print array will do, it will create a new instance of that class of the list. So print array, it is new, it will take the list directly from here. So whatever the array elements that you are having, so these are given to that, and it will take one by one element, and it will print it back. So this is invoking the method. When you invoke it directly, what is happening is the print array method will get the anonymous arrays, and the values will be printed. Right. So the statement print array, like what we did now, 312642, creates an array using the following syntax. So it is this what we are doing. We are doing new data type. So 0, 1, 2, literal, so on up to k. There is no explicit reference available for the array. Such array is called as anonymous array. So we are using directly the array that we are having anonymously. So we call it as an anonymous array. So you can see here that we are using directly the array that we are having to declare as a new array, and we call that one as an anonymous array. Okay, so now in method passing, you have two ways. One of them is pass by value and the pass by reference. So now we will look into pass by value. So Java uses pass by value to pass parameters to a method. There are important difference between passing a value of variables of primitive data type. So there is a variation. So there is a difference. What is the difference? When you are giving the values of a variables, and also if you are giving the primitive data types, and also you are having how do you pass with the arrays. For a parameter of primitive type value, the actual value is passed. So whenever you are having some value, that value can be directly passed on to the method. Changing the value of the local parameter inside the method does not affect the value of the variable outside the method. So whatever you are doing, local parameters, it will be done inside the method itself. Like when we were discussing about the topic on methods, I told you how those things works. And here, when you are doing any changes inside the method, it will be reflected only inside it, and it is not going to affect outside the method. So for a parameter of an array type, the value of parameter contains a reference. Now we are talking here about as a primitive data type. So when you talk about the primitive data type, we give here as a reference to an array. This reference is passed to the method. Any changes to the array that occurs inside the body method will affect the original array that was passed as argument. So now, because you are giving the reference, so whatever the changes that you do inside the method will affect the original array. So that will affect the original array. So there is a difference over here. So pass by value, pass by, pass by value, and pass by reference. So pass by value will not change anything because it is local. So pass by value, if anything is declared inside the method, it will be only within the method. pass by reference because you are referencing something. So whatever may be the changes that you are having here, that one will be reflected back and it will be passed out. So this is reference because you are getting the reference here value. So the value will come, the value will return inside the method and nothing will be returned back and nothing will be reflected here. But here the values are referred as a reference. Any changes, those changes will be affected and those changes will be returned back to the place where the reference was taking place. Okay. So see here as an example. So we are having public class test, static void main string args. So we have one variable and we are having one array declaration. So integer of size y is equal to new of integer of 10. Okay. So two things, one is a value and the other is an array. Now I am calling a method, invoking a method m of x comma y. So what is m of x comma y? It's a method where you are having two actual parameters that you will use. So I will declare it later on. And when it prints, it is printing out x value and it is printing out the y value. So now what is the x value? So it will call the method and the program will directly go to the method where it is called. So where is method here which is called? Yes, so this is the m method. It is getting two values. One of them is x value and the other one is a y value. So here you get the x value and here you get the y value. So what is the x value here number? It is x, right? And what is the number here? It is directly the integer that we are going to use. So now system.out.println x is plus x. So now the value is locally used. So you can see here that x value, so it will directly print only the value as x is equal to 1. Now y of 0 is what is the value of y of 0. So for example, now you are writing a new number here, 10001. So now you are changing the value, assigning a new value to 1001 to the number. And for this array, at the number of 0th position, you are giving 5555. So you are giving 5555 at the number index of 0. So this one 1001. So this is locally to the method, but we are using this as a pass by value because this is directly the value that you are using and this is pass by reference. So pass by reference will return the value when it is changed. So you can see here that for the first statement, x is the 1, though x is there, but we are changing the value as 1001 here, but it is not reflecting change. Why? Because we are having the value. Now check the second statement, number of 0 is equal to 5555, right? So 5555, but it is returning when the method is called m of x comma y. So the number is not affected. Why? Because it is locally passed by value and the other one is passed by reference. So the original variable x in the main was unaffected by the change to the number 1001 in method m because x was passed by value. So that's what I said. X was passed by value and the next one was passed by reference. I hope with this example it is clear what is passed by value and passed by reference. Next. So how does this happen? So when we were invoking the method m of x comma y, the values of x and y are passed to numbers and numbers. Since y contains the reference of the array, numbers now contains the same reference of the same array. So that's what we were doing here. So this is where we are having an activation record for the method m, and this is the main method. So in the main method, we are having one variable and we are having the array variable as a reference. So when it is passed on, it will directly reflect over here and the other value will be directly reflecting as a reference. When you pass on the reference, it will go here. Whatever the changes that you do for a method, those methods will be getting over here because you are using array as a reference. So an array of 10 integer values is stored here. So that's where the references will be used for swapping of the numbers or changing the array's values. So similarly, as an example, how Java manages memory for methods, arrays, and variables using the concept of stack and heap. So you are having a stack and heap over here whenever we call on using the memory as methods. In compares two scenarios, a method that swaps two primitive values. So that is, it is swapping the numbers here. On the left side, you can see we have n of 2 and 1. A method that swaps the first two elements in an array. So it will swap it out. And the second thing is swap first two in an array method right side. So now the other one is only swapping in the array method. So here it is only swapping the values, and the other one is swapping in the array method. So when invoking m of x comma y, the value of x and y are passed to numbers, and since y contains the reference of the variable, so here it will change. So say for example, here you are having n1 is 2 and n2 is 2, but initially the value of a of 0 is 1 and a of 1 is 2. So when you are referring and swapping it out, it will change those two values to be changed, because as previously discussed, we are having. So here we are having two methods. One is swap first two arrays. So we have here swap two arrays, and this one activation from the main method, and this is an array, and this is this one. So you can see how the example works out. So with a real example that you can see here, it makes the things clear. So now I am having a method called as void swap. So these are temporary variable where I want to swap the numbers. So say for example, you are having the numbers as 10 and 20, or here it is given already 1 and 2. So I am having the main method, an array of a and 2, and now I am calling the method with a of 0 and a of 1. So this one is a of 0, this is one value, and a of 2 will be 2. So now I am calling this one with these values, so numbers. So now temporary variable is created, which is equal to 1, and n1 is equal to 2, and n2 is equal to 1. So this is how the changes goes on. So when swapping the first two in arrays, Java pass a copy of reference. So now why there is a change here in first two array? Because you are using an array, you are getting the same operation, that is changing the numbers. Now here I am having 1 and 2. So swap first two elements in an array. So the activation record for the first swap two arrays contains a local variable array, which points to the same heap. Inside swap, first two integers changes to array 0 and array 1 directly affect the same array in the heap. So it will directly change it out over here. After swapping, the array in heap becomes a of 0 will be 2 and a of 1 will be 1. So here you are using an array. So swap the first two arrays. So you are calling directly the array over here as an A. So the method name is swap first two elements in an array. So swap first two elements in an array. So you are giving as an array size. So a of 0, a of 0, a of 1, a of 1 is equal to 10. So that one is directly changing the value. So here you are using directly the values passed by values, and here you are using the pass by references, as you can directly say here that array is an array that you are going to use and you are giving as a reference. So that was the previous example that you saw where so excuse me. So the JVM stores the array in an array of memory called the heap, which is used for dynamic memory allocation, where blocks of memory are allocated and freed in an arbitrary order. So whenever we are having the changing in the takes place, it goes to the heap, and the heap can change the variable references or the method value references. So here is an example, variable length arguments. So you can just have a look into this example where we have a public class var arguments demo. We have a main method. So we are having two arrays. One of them is directly the values that we will use, and the other one is directly we are having the numbers. So we are calling the print max methods in two different times, the same time, one time with the arrays and one time with the values, with the numbers. So public static void print max double with the numbers, so all the numbers. If the number dot length is equal to 0, that dot length will get you the number of values. So no arguments are passed and return 0. So whatever may be the number that you are having, if that numbers is equal to 0, so nothing will be passed. And then we say that double of result is equal to number of 0. So we want to take the initial number of 0. For I is equal to 1, I is less than numbers dot length. So if number of y is greater than result, result is equal to number of I. So it keeps on finding out the maximum numbers. As you can see that whatever way the result that we are having, that will be the maximum. So from the arrays that we are having here, let's go to the first one. So you can see here that print max 34, 3, 3, 2, 56.5. So directly what we are doing here, we are calling the method over here where we say that public static void print max. So we are calling this print max method and we are giving the values as 34, 3 and all those things. So now if it is length is 0, no. Now we take the result as a variable and then we take the first value which is 34. So the number is 34 first. For I is equal to 1, I is less than of number of length. So the number of length 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. Sorry, 4. 0, 1, 2, 3, 4. So yeah, 4. So 4, if number of I is greater than the result, so if the number of 1 is greater than the result is 34, then the result will be number of I. So the second number 3. So if it is bigger, it will take. If it is bigger, it will take. So keep on repeating it and until it finds the biggest number. So you are getting the number as the result is 56.5. Now, the second time what we are doing here, there is all just like that. So now what we are doing here, calling the second method, print max of with an array. So the same thing with an array. So if 1, 2, 3, so print max is called again with the double of numbers 1, 2, 3. So now if the same number is equal to 0, it will put it on. If not, it will check. So the same thing here, 1, 2, 3 is checked one by one by one, and the maximum is this one. So the first one, pass variable length argument list, a variable length argument parameter list. So a variable length arguments that we have. So double number is a variable length argument. So where we are having parameter, it allows passing any number of double values. So you can pass on any number of double values in your programs. So that's now another example that we would like to see here is returning array from a method. So now I want to get the reverse of the list. So you are having a method called as reverse list and giving the list and returning the list. So we are having the parameters as a list and the return type also we want it as a list. So now we created integer results as a new list and pass it on. So from I is equal to 0, j is up to length, that is of the reverse. If keep on repeating it, so take the first element and then keep on reversing the elements. So we have here list 1 and list 2. So the list 1 is nothing but it is the reverse of list 1. So whatever will be the elements that you have 1, 2, 3, 4, 5, 6. So those one will be reversed. So we start from the first value and keep on repeating it until the length of the list becomes 0. And every time I take the first value and keep on incrementing it and decreasing the previous results. So it gets you to the end when you are having the reverse of the values to be printed. So like again for the same example, so here I am having list 1 and list 2 and I am having to make the reverse of this list. So the method that we are calling as a list and then from the starting, so declare results and create an array. So we are doing it. So now we are having 1, 2, 3, 4, 5, 6 and we want the result is equal to, it's a new list same as to that of the list that is of the length. So whatever may be the list that you are calling it up, so based on that you can get those numbers to be printed here and keeps on repeating the values. So starting from I is equal to 0 until it goes to the 5 because the index keeps on repeating and check every time from the first value then the second value, so it has to decrease and we keep up to the length of that. So you can see that If it is there, the numbers will be keeping on printing. So that is I is equal to 0 until it's less than the 6. So the repeat of the loops takes place. And here the numbers will be reversing it back from 1 to 2. And then the second time it will be 2 here. The third time it will be 3. So whatever the list that we are having, we get up to the reverse of this. So every time it repeats, so the list will at the end when the list is ready. So if it is less than 6 is false, so exit the loop. So the list 0, 1, 2, 3, 4, 5. So if it is there, it will go on, but if it is less than that, it will go. If it is equal, it will directly stop. So the condition is less than the list of the length. So the length will be reverse and you get the reverse of the list. Okay. The next topic for us is about what you called as searching the arrays. Now, application of arrays is also helped in searching the arrays. So what is this? Searching an array is the process of looking for a specific element in an array. Specific element. Say, for example, I am having an array where I have an array like, for example, I have some values 50, 20, 30, 10, and 70. So say, for example, I am specifically looking for some value in the array. Does it exist or not? So say, for example, I am looking for 20. So I start from the first array index, 0. If it is equal to the 20, no. If this is equal to 20, yes, this is equal to 20. I have found that element in particular index. So the arrays is many a times it happens that you need to do some jobs in the programming. So searching is a common task in computer programming. There are many algorithms and data structures devoted to searching. In this section, two commonly approaches that we will be learning is about linear search and the binary search. So very useful technique in programming. You may be facing situations where you are asked to search uh, in some of the lists. So how to do that one? We will see what is this particular things that we are having. So public class linear search. So I am declaring a class as a linear search. And in that, I am making a method which is public static integer linear search. So I will get that as a list, which list you want to search, and what is the element that you want to find out. So that is what we call it as a key. So just now I have drawn a array and I ask for the key element to be 20. So what I will do, I will start from the index 0. I will start looking for that until the length, and every time I check, after that I have to check for the next element. So whatever may be the key element that you are using. So for example, I told you that you will be looking for 20. So 20 is equal to the list of the index at 0, return it. If not, return -1. So the keep on returning it, checking it, checking it. So when you get that value, it will return that index or it will return directly the -1 value. So list, so keep on repeating over here. Key compare with the list I for I is equal to starting index and it keeps on repeating it. So this is a very simple technique which is linear search. It will look onto it. So the linear search approach compares the key element, which is the key, sequentially. So one after the other elements is searched with each element in the array list. So it will check, this is the element, is this is the element in the list. The method continues to do so until the key matches an element in the list or the list is exhausted without matching is found. So it will look. So here, for example, I am looking for a 70. Say for I have a list here, 3, 50, 20, 70, and 90. So I am looking for this in 70. The key element that I am looking for is 70. So starting from the index 0, is it there? No. Is it the one? No. Is it the one? No. Is it the one? Yes. So return that index. So whatever may be the position that you are having, you want to return the index. So say for example, I am looking for 80. So key element is equal to 80. So linear search starting from this, no, 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 no. So in that case, it will return -1. So if a match is made, the linear search returns the index of the element in the array that matches the key. If no match is found, the return is always returns as -1. So in the first case, 70 is found, so it will return the index. So the index of this 0, 1, 2, 3. So the answer will be the index for this. Now in the second case, we are looking for 80, starts from index 0, 1, 2, 3, 4. There is nothing over here, so it will return the answer as -1. So if no match is found, the search returns as an -1 as an option. Okay. So with an animation, let's see. We are looking for 3 in the list. So it starts from the index, starting from 0. No, not found. Then index 1, index 2, not found. Index 3, index 4, yes, found. So now you get to that particular value starting from the list to the end. So if you want to look at the live example, so we would be thankful for this website where we can have a look at the live example that how the linear search works on. So to get experience with this, so you can see that this is the list that we are having. Now, what is the key that we are finding out to perform a linear search? Enter a key, a number, click the next button to perform one comparison, click the reset buttons to start over. So how much key size that we have? 1, 2, 3, 4, 5. So you can reset it. Say for example, I am having 8, reset. So now the list is 1, 2, 3, 4, 5, 6, 7, 8. So what is the element that you want to find out? Maybe for example, I want to find out 90. So is it the index is found at 0? No, the element is not found. Is it found at second, that is index 1? No. The third one, the second index, the third index, yes. So test is equal, if 90 is equal to 90, a key is found with the index 3. So similarly, let me reset it. How many number of elements that you are having to look for? Say for example, I want the number of elements to be 8. Again, say 9, for example. So what is the element that you want to find out? So say I want to find out next. So 90, is it found? No, no. So it is not there, 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 it is not there. So if no matches and the search is exhausted, it will return -1. Say for example, reset again, and here I am looking for 71. So next, next, next. So no match, keep on continue, no match, no match. So index is, so this is index, a key is found with the index 5. So it is found. So search finished. So click, so you found it and the searching will stop. So that is where we call it as a linear search. I think it is clear. So how do I make an program out of it? So the method that I can look for is the method for finding a key element. So here I am having a method name integer search. So it will return the integer type because it is getting the answer as the index as well as -1. So now I want the list to be given as an argument and also as a key that you want to find out. So what it will do, it will start from the index and keep on repeating. If the key is found, check. If it is there, you get the index. If not, it will return. So here you are having 144 as a list. So now I want to search with a linear search and get the answer to the integer I is equal to, call the method as linear search. What is the list that you are having, the list that I give, and what is the element that you want to find out. So the element that you want to find out is 4. So start from 0, 1. Yes, it will return 1. Now list again, -4 is the one. We are keeping on looking. It is not there, so it is returning -1. Now again list, start from 1. Is it, what is the element that you are looking for? -3. 1, 2, 3, it keeps on reading -1. Yes, it is found at the index 5. 0, 1, 2, 3, 4, 5. So we found out at the index 5. So that is the linear search example. So if I just want to see the element in the program, how do I write? That was the one that I just now showed to you, that public class linear search. This is the class. public static integer linear search, and you are getting the list and the key. So here you are having, and you want to find out the key element is 30, not equal, next, next, next. So here it is 30 is equal to 30. So it will return the index of that. So that's how it will return the values, and if not, it will give the -1. That is what we have is for the linear search. The second type of search, what we would be interested in looking is a binary search. So what is a binary search? For the binary search to work, the elements in the array must already be in the ordered. So we should have an ordered list. Without the loss of generality, assume that the array is in the ascending order. Say for example, you are having this one and this is in the order. So binary search always has to be the list in the order. The binary search first compares the key with the element in the middle of the array. So now if you are having an array size, it will, and the key value that you are looking for, you can check with dividing the array into half and see that it will check the array element if it is found in the first part, half of it, or it is found in the second half of it. If the key is less than the middle element, you only need to search the key in the first half of the array. Say, for example, uh, how many elements that we are having here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it will divide this 6 into 6, and we are having a middle element 1, 2, 3, 4, 5, 6, and this one is the middle element. So we are having 50. Now, say for example, I am looking for the value which is 11. So now 11 will be searched in the value 11 is less than 50. So it will check on the left hand side. If the value is greater than 50, let's say for example, I am looking for an element which is 70. So now 50 is less than 70. So the element will be looked on the other side, on the right hand side. So if the key value is in the middle element, the search ends with a match. So if that element is directly the middle element, so that's it. If the key is greater than the middle element, you need to search the key in the second half of the array. So you will look for the second half. So let's see an example here with the animation. So say for example, we are having the list 1, 2, 3, 4, 6, 7, 8, 9. So we are looking for key 8. So it will check the divide and see if it is there in the half of the list. No, if it is not, so it means that it can be on the other side of the list. So because 8, so if it is not there, then it will go to the other side of the list. So now you can say that it has to be on the other side. Yes, so this one is on the other side, it will directly get you to that. So similarly for another example, so we have a list here and see that the list is ordered. The list is in the order of the list. So we have an elements of 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we are having 13 elements and we are having index of 12, and we will take up the key in the value that we are looking for is 11, and key value 11 is, make it into middle, half of it. So you can see that out of 13, 1, 2, 3, 4, 5, 6 elements on the other side, 1, 2, 3, 4, 5, 6, and we are having 50 as the middle element. Now, when I start looking from the middle element, the key that we are looking for is 11. So for sure, 11 will be checked and it is found out that it is on the other side of the list. So now it will directly keep on looking for this one, and you can get to that particular place where you are having the value to be searched for. So the list is done again. So the list is truncated and you are having only this list to be checked. So what is the highest value that we are having here? 45. And what is the low value that we have here? 2. And then we get the middle of it. So the middle, you can say 7. So now 7 is the middle element. You can just check here the index 1, 2, 3, 4, 5, 6. So the third element, you can just check and say that which is the next element. So you are having the 11. So 11 is not on this side. So it has to be on the other side of the list. So other side of the list is 10, 11, 15. Now you are having directly the value that is 11 in the index of 4. So that one will return. So this is binary search, the list will be need to be in the order. You have to take the middle element and then nearest, you can keep on looking for the values to be on this side or the other side. Say for example, we are having one more key into look into is 54, so it has to be in the ordered. Now check from the middle where it is on the left side or on the right side. So it is 54, so it should be on the right side here, and then we make again the values in a way that it has to be distributed, and just take the middle element, and we are saying that 66 and we are looking for 50. So discard this, we will be having the elements that we are looking for. So this is 59 and 56. So sorry, 59 and 60 on this side. So we are looking for 54, but it is not found in the list. So you will get -1 as an answer. The binary search method returns the index of the element in the list that matches the search key if it contained in the list. Otherwise, it will return insertion point -1. So if it is there, it will return the content. Otherwise, it will return insertion point -1. So remember this point. So if it is found, it will get you to that. But here in our case, 54 is not found. So it will get you the insertion place that we are looking for -1. So what can be the position where it can have this? So this is the position that it can have this. So it will return the insertion point is the point at which the key would be inserted into the list. So if you are inserting in the list, so what would be the position that you are talking about? And from that, you have to always remember -1. So say for example, how do I write in a program? So we are looking for binary search. We have a list and we are having a key. So we start with a high number and see how it is did. We divide that into half of the list. If the key element is onto the middle of the list, directly you can get it. If it not, if it is less than that, you will see on the other side. And when you are returning, it has to return the lowest key as -1, and then you will return the position of it one. So that's how the program will look for. So to more explanation about this, so for example, you can see as we are talking about a binary search, and we are having a list of these elements, and we want to search for an array of binary size from the list, and the key element that you are looking for is 11. So it will start making it is in the order that we are having, and you can see that we have 1 2 3 4 5 6 7 8 9 10 11 12 13. So divided into 6, 1 2 3 4 5, and here it is 6. So here it is 1 2 3 4 5 6. So the middle element that we have here is 50, and now we are looking for 11. So 11 is onto this side of the list. So it will now truncate this one, and we are getting this. So now again we have the list 2 and 45, and then we want to find out the 11. So make this one as a point. So now the 10, so remove this, and now we are having only that list to be looked on. So we have, so what is the index now? 0 1 2 3 4. Yeah, so that it will return the 4. Now, for example, if it is not found, so we have an array and we are looking for the character at t. So this array is of characters. So now we are calling java.util.binary search as a method name that we want to go for it. So we will be looking into the character. So this one is divide again into the same thing here. We are looking for t. So we have this one on this side. No, we have this one on the other side. So t is in between. Sorry. So for this is with arrays, right? So arrays means you can start with the letter A, B, C, and all those things. So that is with the arrays that we are having. So returns -t with, so it -3 -1. So t is between G and X. So now that letter that we are looking for is between G and X. So the first element is greater than t is X at index 3. Insertion point will be at this particular place, and then we are having -3 -1. So here you have to see that whatever may be the nearest element that we are having to use, say for example here we are having t, and instead of t Say, for example, we want to insert M. So, for example, we want to for search whether M is there or not. So, M means again A, B, C, D, E, F, G, H, I, J, K, L, M. So, G after G only before this one. So, it will be returning you the same position. So, for the binary search method to work, the array must be pre-sorted in the ascending order. So, always remember that point that it is going to be -3, -4, -1 according to the index where it is being inserting. That's the value will be returned. Now the next thing is after the search, we are having the next topic to look into is sorting the arrays. Sorting arrays means arranging them automatically in an increasing order. So a common task that you are doing in computer programming. So for example, it would be used to initiate instance if you wanted to display the grades from listing 6.2, assigning the grades in the alphabetic order. So many different algorithms have been developed for sorting. So in this section, we will do selection sort and insertion sort. So under the sorting arrays, we will talk about selection and insertion. So what are these? Now, this is a list that we are having and we want to do sorting that 2, 9, 5, 4. So we want this one to be arranged in sort. So it means that the list should be coming from 1 to the maximum number that we have here is 9. So the list should be, it is not in a sorted fashion now, it is unsorted. So you want to get it in the sorted order. So how the insertion sort algorithm works? So the insertion sort algorithm sorts a list of values by repeatedly inserting an unsorted element into a sorted sublist until the whole list is sorted. So it will keep on repeating. So let's see this example. So 2 and 9. So yes, 2 and 9 are in the order. So it is no problem. Now it comes 5. So now 5 is smaller than 9. So what it will do is it will insert the things. 5 will come here and 9 will move to the next. So here we are having 259. So after 259 we have 4. So 9 is bigger than 4. So 4 should be on the other side. So 4 will check with this 9. It is bigger, sorry, smaller. 4 will check with the 5. It is smaller. So now it is inserted over here. Similarly, now 2, 4, 5, 9 are sorted. Now we have the next element is 8. So 8 checks with the previous one, 9. So 8 is smaller than 9. So it will come up over here. Similarly, we have the next element is 1. So 1 need to be checked to the last, the first element. It is 1. So it comes over here. Now after 1, we are having 6. So 6 will check with the 9 and with the 8, and then it is inserted over here. So this is entire list is now sorted. So you check for every sorted list, and when it is done, you are inserting that key element, key value back into the list wherever the list can be seen that it is smaller than the value in the arrays that you are having in the list. So it is bringing you a sorted list just by shifting the place where it has to come and do that. So that is where we call it as an insertion sort. So now, for example, again, you can see here that this list is there. This is unsorted. So how we can do that? So now 2954816. This is the one. Now 5 has to be come up over here. Then the 9 will shift there. So 5 comes over here, 9 shifts here. Then we are having the 4. 4 should come over here. It will check with this and it will check with that. So now 8 is there. 8 need to check with this. And then, yes, it has to come to one place. So now comes here, go for the 1. 1 will directly come on the other side of the list. And then we are having 6. 6 will come over here in the after the 5th position. So you are having sorted list. So if you want to look at an animation, so you can even look at this particular animation for insertion sort. So thanks to the people who has, yeah. Now we have a list. So you want to perform a new random list is created. So now you want to have a sorted list as whatever the list that you are having. So let's start with these numbers, and then we keep on increasing the numbers as such. So step, so this one is smaller than this. So next, 5 checks with the 86, and then 5 also checks with the 7, insert, and comes over here. 3, index 3 checks with these. 3 numbers are moved out, and then we are having the number to be inserted over here. 54, so where it comes, this is the place where it comes, and so now 13 is the place where the 2 shifts has to take place, and then we are having the number 13. So insert 9. So insertion, sort, insert and keep on sorting. So now it keeps on changing this particular place one by one, and you can look into it. So if you want to get more practice, you can just simply go to any of those this link that I have shared on the PowerPoint, and then you can continue looking onto this list with different examples. So that is where we are having the insertion sort. So so that was the one example that I showed with you. Now here is the same example that what we happened. The algorithm was working in a sorted list. You can refer to the slides. So temporary variable, it will be using it and moving out list from one place to another place until you get a sorted list. So insertion sort, this is how to insert. This is the insertion sort that we are looking for. And you can see how the insertion will bring it up over here. 2, 9, 5, and keep on repeating that process until it is done. So this one is insertion sort 2954186. So that example that we have taken care about. Okay, so this one is the programming part, how the programs can be created, where we are having I is equal to integer I list dot length -1. So until it keeps on repeating, and swap the first list, and every time it checks, the list will be repeated. Now the last thing that we have is in sorting, is the next sorting example is about the insertion sort. So how the insertion sort will work. So here you can see that selection sort is a simple comparison based algorithm. It works by repeatedly finding the minimum element from the unsorted part of the list and swapping it with the element at the current beginning of the unsorted part. So what it will do is finding the minimum element. So from the list, it will scan the list completely and check for the smallest one. So let's see this example here. 6425. So this is not sorted, so it wants to sort it. So what is the smallest element that we have? The smallest element that we have here is the element number 11. So the element number 11 or the element 11. So now swap 11 with the element at the first position. So the 11th will come because it's the lowest, and it will come from the last position to the first position. So 11 is inserted in. So now we are having the next list. So from that list, again, what is the minimum that we are having? The minimum that we have is 12. So 12 comes immediately after the 11, and then you are left out with 22, 20, sorry, 25, 22, and 64. So now what is the minimum out of it? 22. Now 22 will come over here, and then check for the next one, 22, 25, 26. So again, it will check for the next two elements, 25 and 64. Yes, 25 and 64 are already in the order. So the sorted array is this one. So that is what we call it as a selection sort. The example is here, selection sorting. Uh, the lowest element is 1. So come to the first one, and then what is the next lowest element? It will be X 954826. So now the next element will come over here. So next element comes over here. So the next element that will, the minimum is 2. So 2 will be moved, and the next element is, keep on repeating this in a selection sorting, it goes on. So another example, this is an original list. So we have the lowest of the element. So 8 comes to the top. And then we are having the next element is 23. So 23 comes up over here. The unsorted list, again, we are having 32. 32 comes out over here. So this is the passing of one by one pass for the list until we get the original list to the reverse order, which is not in the reverse order, but in the sorted order. So this is an example that you can write with the program. So public class selection order, selection sort from the starting, the minimum, the maximum that you are having, and the current index X of the values that we would like to check on with. And what is the minimum index? What is the maximum index? The repetition of the loop will check. If it is less, same algorithm that how the swapping things that I were working on. And next, so one of the other sorting algorithms that you may come across is what is called as a bubble sort. Um, Bubble sort is, from the name, it is clear that bubble sort. So it is swapping with the next element and see what is the order that we are having from this. So for the first element, it checks the first element. So in the first pass, so for example, we are having this list. So in the first part, so 2 is there, so 2 and 9 is there, so that's fine. So 2 is in the first order and 9 is the second element. But now you check 9 and 5. So 5 is smaller, so it will sort it out. Now, after that, what are the next elements? The next two elements are 9 and 4. So it is not in the order, so it will go to 4 and 9. And next elements is 8 and 9. And the next element is 1 should be before 9, so it is 1 and so in the first pass, so from the first pass 295481, and we got only bubble, like you change the values in between, you are smaller, you are bigger, it will change. Now after the first pass, the values are passed on to the second pass. Now again the same thing, 2 5, okay, 5 4, not okay, so 4 5 will be changed here. Now, after that, 5 and 8, yes, it is correct. But the next pass, next round, 1 and 8, because 8 and 1, no, it has to be 1, 8. And the last one is 8 and 9, that's fine. So now, after the order, 2, 4, 5, 1, 8, 9. So it will go over here. Now you are having 2, 4, 5. Okay, up to here is fine. But 5 and 1 is not in the order. So it will change from 1 to 5 and 8 and 9. 8 and 9 is okay. 5 and 8 is okay. So now we are having the pass on to this 2, 4, 1, 5, 8, 9. But 2 and 4 are okay. 4 and 1 is not okay because 1 should be before. So it is sorted now. 4 and 5, 5 and 8, 8 and 9, or are perfectly correct. Now pass it on to the next 2, 1, 4, 5, 9. So 2 and 1 is not okay. So 1 should be before. So 1 and 2 will come, 4, 5, 8, and 9. So this is until the fifth pass. So you have this, and you can watch at the video of a bubble sort how the animation will be working. So let me just quickly go to this one to show you how this one works for the bubble sort. So say for example, we are having a list is created randomly. So 48 and 9. So 48 and 9, it is just changing over here. Or let me start again. So 48 and 78 is fine, but 78, 40 is not fine. 48, 78 are fine, but 70 and 48 are not fine. So it is changing. Now go to the next one, 78 and 48. So it is changed. Now 78 and 14. Yes, 14 should come first. Then 78, 54. Change. 78, 32, there will be a change. 78, 72, there will be a change. 78 and 14, there will be a change. 70, there is a change. There is a change. Next, yes, there is another change. There will be no change, 78, 88. So next one, 43, 88, there is a change. 88, 54, there is a change. 88, 46, there will be a change. Yes. Now that is a pass. One is completed. Next, again, 48, 40, yes. there is a change. 48, 14, there is a change. 48, 54, there is no change. Next, 54, 32, there is a change. 54, 72, there is no change. 70 to 14, there is a change. 70 to 69, there is a change. So it keeps on repeating in that format where it, so that is the animation that you can look for in the bubble sort. And the last one of the other sorting technique is merge sort. So here in merge sort, what will happen is it will divide the list into half and then split into two different lists, and the ordering will be done on the first part and the second part. So you can see here, same like previous one, you divide it and 2, 9, 5, 4. So you split again 2, 9 and 5, 4. Are they in the order? Yes, they are in the order. 5 and 4, they are not in the order, so it will replace 4 and 5. Now 2, 9, 4, 5. So now 2, 9, 4, 5, are they in the order? So no, it is 2, 4, 5, 9, it will be no. So similarly, 8, 1, 6, 7. 8, 1 are in the order, 6, 7 are in the order. Yes, 6, 7 are in the order, but 8, 1 are not in the order. So merge it and sort it. 1, 8, and then we have merge it 1, 6, 7, 8. So now you check the merging of this one. So there is an divide and conquer type of thing where we divide the array size based on the list, and then first half merge the sort first half, second half merge the sort second half. So we are calling repeatedly sorting algorithm based on the list that we are having here. Maybe this list, maybe this list, maybe this list. So the list keeps on repeating and you get until the merge is correctly sorted out. So you can see the same example that I did now, 2, 4, 5, 9, 1, 6, 7, 8. So we are merging it out. So 1 is there, and then we look for the sorting of these two sorts. So 2 will come, 4 will come. After so many number of times, the merge sort things will be working it out. So this is some of the example that we are using as an array to make a two-dimensional array, where this is for evaluation of the student grades. Like there are some multiple choice questions the student has to answer, and these are the answers that the students has given: student 0, student 1, student 2, and there are totally 10 questions, and every student answered it differently based on their understanding, but there is one key answer which is the right answer to be checked. So I want to make an program where the students has answered on their own, and I have an answer key which is the right answers. How can I make a program to check how many students have made the correct answers, how many of them get the grades? So you can see that public class grade marks main string. I am declaring the answers from the students, whatever may be the answer that they have given. A, B. So I have 8 students. So 1, 2, 3, 4, 5, 6, 7, 8 students are there. And how many answers we are having? 10. So it is a two-dimensional array matrix. Now, what is the answers key that I am having? It's only a one dimension. So this is the answer key that I have. Now I have to take every student and check with this. So index starting from 0 up to the answer dot length. So whatever may be the answer up to here, we are having 8. And then if count, correct count for j is equal to 0, that is the other loop that I want to go inside. J is less than 0 dot length. It keeps on for the first array. Then compare the answers with the first answer with that of the array answer over here. If it is correct, count it. If not, go to the next one, go to the count. So overall, it will count, then it will give you the count, the correct count in the correct counter answer that we are having. So that's how the arrays will be useful in traversing towards the arrays and getting the answers out of it. So with that, we complete our lecture number 8, and this is for you to have a look into that. And if you have any doubts, we can discuss it in the class, and also you can discuss with your tutorial instructors. Thank you for watching, and see you next time.